We are going to continue to simplify rational expressions today, but we're moving into using operations with them, multiplying and dividing them. Today, multiplying, and then we'll have a day 2 tomorrow where we divide. Okay? So if we have A over B times C over D, we already know what that is. What is that, Kyle? We're just multiplying, so AC over BD. So which variables may not equal 0?
D or C or
B or D, right? B and D may not equal 0. If they were 0, we would have undefined expressions. So we wouldn't be able to have a real answer for them. How about with our division? When you have A over B divided by C over D, now what do you have? Really? Kyle? Good job. So he is multiplying by the reciprocal. Now, this is an interesting question. Which of the variables may not equal 0?
B or C.
We look here, everyone is looking at this simplified expression and saying BC, and that's true. B and C may not equal 0. However, what else may not?
D.
D, good job. We've got to look back. So when we receive an expression, we may not have an undefined ratio anywhere in it. So D may not equal 0. It now becomes a numerator. C is now in the denominator. It may not equal 0. So B, D, and C all may not equal 0. You may end up with excluded values in any of these areas. The two denominators of the original, and then this numerator, which becomes a denominator. So what is the method of multiplying rational expressions? Fractions. In 4th grade, when you start to multiply fractions, what do they teach you? Matthew? Multiply across the top. Good. Multiply across the bottom. So when you have two fractions that are being multiplied, you really could just extend the bar across. So if you're going to work right on the expression given to you, change to a red pen when you're writing on it so you see what the original one was, right? There's more than one way to simplify this kind of stuff. But if I bring it together, I could, just rewrite the whole thing. 8x cubed. This is all multiplication, isn't it? And probably you don't want to write it over and over again, but everywhere we see multiplication. We could combine it together, those like things, and we could say 3 times 8 is what? 24. And then how many x's do we have in the numerator? X to the 5th over 2 times 15.
30.
I don't even like to multiply together. I like to leave it in factored form. And how many x's? 2. So when it comes to the constants, the coefficients, what is 24 divided by 2? We can simplify there and call that 12. And then where do we have x's left if we simplify the variables? How many do we have in the numerator? 3. So we could write this as 12x to the 3rd over 15. Ooh, is there any way to reduce that? 3's, okay. So we'll divide out 3's and call it 4 over 5. So 4x to the 3rd over 5. Now sometimes people want to work right on the original, and we've done this before, haven't we? Where we say, here are 2 x's, get rid of those 2. 2 goes into 8 4 times, right? 3 goes into 15 5 times. And it can get kind of messy, but if you can read your writing, what do we have left in the numerator?
4
Over, and there's just a 5 in the denominator. So you may do that as long as you are able to read your writing and keep organized. Okay? Let's try it again. It helps that type of student out. So in this case, we're going to bring everything in the numerator to the top, right? So we have 2 times 15 times, how many y's in the numerator? Good, 6. And in the denominator, I've got an 8 and a 5. And how many y's? 6. So if you choose to rewrite, you might want to have like things stacked, right? y to the sixth is common to both the numerator and denominator. And how else can we reduce this? Okay, she says 5 into 15, how many times? 3, and then 2 into 8, 4. It's kind of strange, but we're dividing 2 into 8 downwards, aren't we? So what is our simplified expression? 3/4. Okay.
We have 18.
Which is how many z's? How many z's in the numerator? And then you have 4 times 14 times. How many z's down in the denominator? Okay, so how did you simplify this?
Well, I multiplied 4 and 14.
But you know why I don't multiply them? Is we're going to end up simplifying them. Do you see the 7 in the numerator? How many times does 7 go into 14? 2. So we end up with 4 times 2 in the denominator, which is
8.
8. And then where do we have z's left, Haley? How many? 1. Okay, so z over 8. You could multiply 14 times 4, and you get? And then you end up with 7 over 56, which you later reduce. Okay? You could. Okay. How about more fun ones? That was kind of fun, but let's have a lot more fun. Here we go. This is where it gets
I like
fun.
when they're finding Nemo. And they
Okay, here we go. And so, once again, we could just extend that fraction bar across, but look at what we have now. We have these beautiful trinomials and
Beautiful.
incredible binomials. So, as we go, to save you time, let's do the factoring. Okay, so looking at, I'm going to do a giant fraction bar. Looking at this first term here, Hank, what can I pull out of these two?
3
3 times what?
x plus, or 6.
X
Two.
plus
2.
3 times 2 gives you back 6. Good. And then if we look over here at this trinomial, we want to find factors that would give us that trinomial. So the first term would be x times x. Good.
It's both subtraction.
Well, you're going to have a negative 12.
Oh, so 1 addition, 1 subtraction.
Plus and minus.
And it's 12, or no, 6.
You need 1 in the middle. So what factors of 12 subtract to give you 1?
3 and 4.
3 and 4.
And 4 will be our negative to give you negative 1 middle. Good. Now, the denominator. What comes out of all 3? Look for the GCF. What is it?
3.
3. So let's pull out a 3. Ooh, how beautiful is that? 3 over 3. And then what, somebody tell me, Oscar, what would we have in our trinomial if we pulled out a 3 here?
X squared plus 6x plus 9.
Ooh, what a beautiful trinomial. What do we call this trinomial? That's it, perfect square trinomial. And then over here, what do we see?
Perfect square
Difference of 2 perfect squares. So we have the sum and difference pattern. We have x plus
2.
and x minus 2. Whew, looking good. We just have that one trinomial to factor.
This is the one.
Before we factor, let's go ahead and find our multiplicative inverses, right? Where can we simplify?
The 3's.
3's. How about x plus 2? Do I have an x plus 2 in the
Yeah.
top and bottom? About anything else? No. Okay, so we'll just keep coming down to simplify by factoring a bit further. Okay. X plus 3, x minus 4, over what is the factorization of this perfect square trinomial? Good. X plus 3 squared, but let's just write both of them out because we need the both, don't we? We want to cancel one of them. And there you have it, x plus 3 over x plus 3.
X minus 2.
Yeah, whatever.
Oh, did I not put the x minus 2? Whoopsie. This one here had to come down. Okay. Are there any other factors that are reducible?
No.
We just have 3 binomial factors, right? And there is no x minus 4 in the denominator. And neither of these are in the numerator. So there's our simplified expression. And you leave it like that. I mean, we could do away with parentheses in the numerator, and we could FOIL out the denominator, right? But your book is leaving their answers in factored form. Okay, so just leave it in factored form yourself. Any questions? This looks simpler than the last one, and it really is, but this sometimes freaks out students. What does a student need to do when you see what looks like a fraction times just a binomial? Very good. You need to put it over 1. And then just, basically, the x minus 2 is in the numerator, right? So we could rewrite this as 4x squared times x minus 2. We're not distributing because ultimately we're looking to find cancelings, right? And then who can factor out this denominator for us? Vivian, can you do it?
Negative 3, positive 5.
Positive 5 and negative 2. Good job. And so what do we see? We see a common binomial factor. So our answer, we don't even need those parentheses. We could write 4x squared over x plus 5, as long as you remember this is simplified.
Did you cancel this on the x's?
Can you cancel out the x's? Is x, Matthew, is this a factor or an add-in right now? Right, if it was 5 times x, you could, but not the way it is. Okay, Cameron is proposing that if somebody divides out an x in that situation, that you owe the class cookies or donuts.
Yes.
Or slash lemon bars.
Or blonde.
Is there anyone opposed to this idea?
Wait, what?
Is there anyone opposed? Speak now or forever hold your cookies. Okay, here we go. Is that a bad joke?
No, it's just funny.
Okay, here we go. This is so fun. Look at all the factoring we get to do.
Aw, fun.
I don't know how much fun you can have in one day, but this is it. Here. Let's back
freezing.
Quick, we gotta do it before.
Yeah, but then we have to finish at the end of it.
Okay, let's try, Aaliyah, can you factor this first one for us? Let's try it.
I can try. X plus and minus 2 and 1.
Excellent, there we go. And what can we factor out of that? Okay, Tosa, what can we factor out of that?
We can do 2x
Good.
and then 1. Oh, x, sorry, plus 1.
Good job. Okay, and denominator right here. The first denominator, what can we factor out of that? Ellie, right here. What can come out of these two?
X times x plus 2.
Good. And then, what can we pull out of this? 5. So we're going to have a double factoring, huh? 5 times what? X squared minus 3x plus 2. Okay. So shall we simplify a little bit here? Sabrina, where can we simplify? Good. There's a factor and there's a factor. What? We can factor further. We got a factor.
Can you cancel the
Here's
x
an
and the x?
Yes, because those are factors. Good. And so let's write what's left. We have 2 times x minus 1 times x plus 1 over 5. And now let's factor that trinomial that was left. Who wants to do that for us? Johnny, what is that? Right here. Good. -2, -1. So do we have more
Yeah.
factors? X minus 1. There you go. So our simplified rational expression, 2 times x plus 1 over 5 times x minus 2. And could we distribute and write it differently?
Yes.
But we're going to leave it in factored form. So that's good.
When you find things you can solve.
There you go. Have fun.